If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on gate analog electronics series. So today we will be solving from question number 66 onwards, 5 questions from 66 to up to question number 70. Okay, then let's try to solve these questions. Okay, in question number 66, what they are asking, the circuit shown in the figure has an ideal op-amp working with plus 5 volt, minus 5 volt. These are power supplies. These are actually saturation voltage. What is the meaning of this voltage? That means internally it is transistors are there inside these two transistors. They are connected. So the biasing of the transistor is done using this. So these you can think of what is the applications while solving numericals. So these are actually saturation levels. That means your V0 output cannot go beyond plus 5 and cannot fall beyond minus 5. If it goes beyond 5, then it will remain at plus 5, and it cannot fall also beyond minus 5. So if it falls, then also it will remain minus 5. So whatever calculation we have learned till now, we will solve in that way V0, and finally we check whether your V0 is crossing this limit or not. If it is crossing, then the limit it will be restricted up to 5 volt or minus 5 volt, upper side and lower side. Okay, now if we start with solving this one, okay, here you can say this is 0, so this potential is at 0. So you can take nodal here because one is coming and current coming is here, current going is here. So you can calculate nodal at here. So suppose this voltage is 0, so this is at 0. So 0 minus this current, if I am calculating 0 minus V0 by 1 kilo plus this current, outgoing current, but because it is incoming, so it is minus 1 into 10 to the minus 3, that is equal to 0. So from here if you calculate, you will find your V0 equal to minus 1 volt. So minus 1 is well within the limit. It is within the limit of plus 5 and minus 5, so it is the answer. If it's suppose minus 6, then the answer could have been minus 5. It will limit at that saturation levels. Okay, next is question number 67. So what is given in 67? The feedback factor of the circuit shown in here. So what is the meaning of feedback factor? Means the feedback that here it is given at positive terminal here. So what is the voltage that you are getting here? The voltage that you are getting here, suppose it is X voltage. So this voltage is how much fraction of V0. Means from output how much voltage you are taking and giving as a feedback. Feedback means we take output and we give it to the input. That is our feedback loop. So that we can check. So how much of that output you are giving as input. So your Vx is how much of V0. That is the question. Feedback factor is Vx is how much of V0. That means they are asking Vx by V0. That's it. So for that you take again a KVL here. So nodal here. So here no current can flow. Because no current can flow, so this voltage will be at Vs. So this will be also at Vs. So you can think of that voltage, or Vs is not required also because you need only one nodal. Relation between Vx and V0. Vs is not required also. Here Vs and Vx both are same. Voltage at X. So if I take nodal here, so it will be Vx divided by 10 kilo. This current, then this current plus Vx minus V0 divided by 90 kilo is equal to 0 because no current can flow in this direction. So only two current, this and this. So if you solve it, you will find your kk will get cancelled, 0 0 it cancel. So Vx, if you take 1 plus 1 by 9 will be equal to V0 by 9, which means your Vx will be equal to 1 by 10 of V0. That is your option D. Okay, in 68 what they are asking, the op-amp having a slew rate of this. What is the meaning of slew rate? Slew rate is change of output with respect to time. That is given 62.8 voltage per microsecond is connected in a voltage follower. Voltage follower means it will follow the voltage only. The circuit will look like say minus plus. So you will give a supply of V in suppose, and you will give a feedback here. So you will get V output is simple as V in. So this is because this is V in, so this is will be also V in. So correspondingly you will get V0 which is equal to V in. This is voltage follower. Okay, so this is my output slew rate. If the maximum amplitude of the input is sinusoidal input and maximum is 10 volt, that means it is 10 sin omega t. That means V output is also 10 sin omega t. Okay, because it is voltage follower. Then the minimum frequency at which the slew-less limited distortion would set the output. That means your output would set at slew rate. Slew rate limited distortion would set the output is Okay, so if I take my what will be my slew rate here? dv0 by dt. So what is v0? v0 is 10 sin omega t. So if you differentiate it ddt of 10 sin omega t, then what it will be? It will be 10 omega cos omega t. So what is the maximum value of slew rate? So slew rate we can say it is 10. So at what frequency this will be equal to your 62.8, that is given. Volt per microsecond you have to think of, that is divided by micro in the denominator, so 1 into 10 to the minus 6 per second suppose I am calculating. So what will be your omega? Omega will be 62.8 by 2 pi into f is given. So f is required, so 2 pi f is required, then 10, then into 1 into 10 to the minus 6. So if you put all these things, you will find it is 99.99 megahertz, which is almost equal to 10 megahertz. That is your option C. For the circuit figure with an additional operational amplifier, the maximum phase shift with an ideal operational amplifier, the maximum phase shift of the output V out, what will be the phase shift with the reference to input? So you need to find a relation between V out and V in, so that you can find what is the shift of angle. If I convert it into polar form, I can get it. Okay. So what will be the potential here? So I don't know what will be the potential. So suppose the potential here is Vx. So the same potential will be here Vx. So we can solve one nodal here and one nodal here. This nodal is not required. This is Vn is divided into two parts, this and this. So you can do a, because this you can say this is a simple loop they are forming. It is a loop. So V in is divided into two parts R and C. So you can divide voltage ratio, voltage division formula, or if you want to go for nodal, so let us go for nodal. So Vx by V in by R should be equal to this current, should be equal to this current, Vx by 1 by j omega c, that is Xc. So if you do it, it will be, I think you can do it. I am directly writing it. Your Vn will be equal to I am directly writing Vx because my Vx is required. So Vn by 1 plus j omega Rc. You can easily simplify it. Do some simplification, do here and there and take LCM, it will come. So once you know this one, now let us calculate nodal at this point, this negative terminal. So what will be nodal at this point? Vx minus V in by R1 is equal to Vx minus V0 by R1. So again R1 cancel. So your V0 will be equal to 2V in 2Vx, this plus this plus this equal to 0, this plus this equal to 0. Outgoings, all outgoings plus 0. So Bx minus Bn by R, Bx by Xc. So this plus equal to 0, which will give you this answer. Again this plus Bx minus B1 by R1 plus outgoing, all outgoing current sum is equal to 0. That is my nodal. So if you solve it, you will find your V0 equal to 2Bx minus V. Okay. So what will be your Vx? Vx if you put it there, so it will be 2 Vn you can take common. So Vn will be equal to 2 by 1 plus j omega Rc minus 1. So if you take LCM here, 1 plus j omega Rc, then what will it will be? It will be 1 minus, if you take LCM, j omega Rc. So now if you want to find the angle of this one, what will be the angle of this one? That is the V in by V0, which is V0 by V in is equal to some magnitude will be there. We are not concerned with magnitude, we are concerned with here with angle. What is the phase shift? So what is the angle of this one? This one, if you see, real part is positive, imaginary part is negative. So this is omega Rc and this is 1. This is the point. This is 1 minus j omega Rc. 1 is real part, this is imaginary part. So what will be this angle? Tan inverse, because it is in negative side. So minus tan inverse omega Rc divided by this angle. The divided by means again, what is the divided by meaning? Divided by means angle will be subtracted. So this angle is this one, it's minus this angle. What is this angle? This was this angle. And if I calculate this angle, it is real is also positive, imaginary is also positive. So it is positive angle theta, but it is minus because this minus this is in divide, the angle gets subtracted. So tan inverse omega Rc. So it will be, what will be the angle phase shift? The phase shift is minus 2 tan inverse omega Rc. So what can be this angle theta? This angle theta can be minus 92 plus 90 because it can be capacitive or inductive, that's it. So you cannot go beyond that. So your Rc means whatever value you change, if you change C, then it can go maximum 90, it can go maximum minus 90, that's it. So what will be the maximum angle shift you can have? So minus 90 into 2 into minus 2 into, here you can go up to 90 degree, either plus 90 or minus 90, depending on your selection. So it will be plus minus 180. That is minus plus, which is nothing but plus minus 180. That much shift you can do here. Next is question number 70. Now what they are asking in 70, assuming the operational diode to be ideal, the gain V out by V in of the circuit shown in figure. The same, it is easy now, operational amplifier. By now it would have been very easy now. So it is 0, it is also 0. So you take, this is also 0, this is 0, because this, and then this is also 0. If I take nodal here, then what will be the voltage? 0 minus V in by 1K plus 0 minus, you need to take this one also. So this one I have to assume as X, suppose, let's. So if it is X, then what it will be? 0 minus X by 10K, that is equal to 0. So from here you will find a relation between KK will get cancelled. So X will be equal to 10 V in. It will be minus 10 V in. So a minus is there. X will be equal to minus 10 V in. So once you know this one, now you take KVL at X position. So what will be the KVL at X? So it will be Vx minus 0 by 10K, this outgoing, plus this outgoing, Vx by 1K, plus this outgoing, Vx minus V naught by 10K. Now if you put is equal to 0. Now if you put X equal to 10 V in and then KK, you all cancelling out. Finally if you do, it will be V naught by V in. If you do it, I am directly writing again minus 120. You can easily do it. You put X equal to minus 10 V in, here Vx, and then just a little bit side change you do, that will come. If you like the video, then press the like button and please give your valuable comments in the comment section.